Hey guys, I'm Daniel, and the question we have here right now is what is the molar mass of toluene if 0.85 grams of toluene depresses a freezing point of 100 grams of benzene by 0.47 Celsius? Alright, and the Kf of benzene is 5.12 Celsius per mol. Okay. Now I know that you can just look up the molar mass of toluene. You can probably find it on the internet, but I think it's very important that you know how to do the actual calculation, because on the exam, I'm pretty sure he's not going to give you the molar mass if he's asking you to find it. All right. So actually the three equations that we're going to be using is the change of temperature for the freezing point depression is equal to the heat of vaporation. All right. Kf times the molality. Okay. And molality, just a refresher, is moles of solute per kilogram of solvent. Okay, and in this situation, we can identify toluene as our solute and benzene as our solvent. Okay, and the molar mass is grams per mole of whatever you're talking about. All right. So let's start off by calculating for the molality. Okay. Since we're given the change of temperature, which is 0.47. Alright, let's write this down. So delta T is equal to 0.47 grams Celsius, and the Kf is equal to 5.12 Celsius per mol. Right? So let's rearrange this equation, move Kf to that side, so you end up getting delta T over Kf equals M. Alright, now let's bring this down here. Delta T, which is 0.47 degrees Celsius, divided by 5.12 Celsius per mol. Okay, and since mol is right here on the denominator, within a denominator, we can throw molality to the top up here. All right, it's equivalent to the other way of writing. All right, so when doing that calculation, let me go ahead and do that now. So 0.47 divided by 5.12 is equal to 0.0918 molals. 0.0918 and moles of solute per kilogram of solvent. Alright. Actually, go ahead and write this down if you haven't, because I'm going to be erasing soon. I'm going to try to squeeze in the rest of our work down here before I have to erase to do some more. Alright. So, the next of our problem is now that we have molality, now we have to try to identify how many moles of solute that we have, because it gives us a mass of solvent, which is 100 grams. Now we have to find moles in order for us to find the molar mass. Alright, so let's go ahead and use this molality equation. So 0.0918 molals is equal to moles of solutes times kilograms, or divided by kilograms of solvent. Alright, so we're given 100 grams. And if you do the calculation or the dimensional analysis, you find that 0.1 kilograms is the equivalent of 100 grams. Alright, so you just divide it by 1,000, you get 0.1 kilograms. Okay, so in order to isolate moles of solute, you multiply by 0.1 kilograms. And I don't want to make this too ugly over here. So 0.1 kilograms. Alright, so when multiplying 0.1 kilograms times 0.0918 molals, we get 9.18 times 10 to the negative 3 moles of solutes. That's what we get. Alright, so let me go ahead and put this in brackets. Alright, now I hope you copied all that down, because I'm going to be erasing now. So now that we have identified the amount of moles of solute that we have, which is moles of toluene, now we use this equation, molar mass equals grams per mole. Now it gives us a mass of toluene. Okay, so we're going to use that mass and put it over this moles of solute to try and find our total molar mass, which is grams per mole. Okay, so we're given 0.85 grams of toluene per 9.18 times 10 to negative 3 moles of toluene. Alright, and our molar mass is equal to this. So let's punch that into the calculator. So 0.85 divided by that gives us 92.6. So molar mass is equal to 92.6 grams of toluene per mole. Alright. Now if you're using the same test, or actually question packet as I am, the letter answer for this this problem is A. Alright, so let's go ahead and write that down. So this is our answer, and I hope you found that helpful. I hope you understand, and good luck to you if you get this in the exam. Thanks for watching.